ready? Okay, so let's now talk about what the book calls logical form. And that's the idea of when one width has the same shape as something we'll call a sentence form. Now, if I just have a variable, that's not an actual sentence in the language of sentence logic. It is a form any sentence in the language of sentence logic can have. Here is a sentence in the language of sentence logic, just that width, or A horseshoe B, or C horseshoe D. And this is a variable. It's called the sentence form. And these are called sentences. And the question that we want to raise is when the sentences have the same shape as the sentence form. So let's start with, let's move to something a little bit easier, and then I'll get back to that one. Here are three sentences, and that's a sentence form. Does this sentence have the same shape as that form? Yeah. You have a horseshoe, and here you have a horseshoe, something to the left, something to the right. Does this sentence have the same shape as that sentence form? No, because that's a wedge, and that's a horseshoe. Does this sentence have the same shape as that sentence form? Yeah. Now, we can go back to this sentence. That really is just a single variable. And you know by definition, a variable is a placeholder in sentence logic for any sentence whatsoever. So it really has no shape. And every sentence has that shape. Because every sentence can be substituted. And that brings in a phrase the book uses to talk about the relation between sentences and sentence forms. If a sentence has the same shape as a sentence form, it is said to be a substitution instance of that sentence form. So the direction is from sentences to sentence forms. It makes no sense to talk about whether a sentence form is a substitution instance of a sentence. So we are always looking, when we're looking at substitution instances, at sentence forms that have variables and no atomic sentences, and sentences that have only atomic sentences and no variables. And the question is, when is a sentence the same shape as a sentence form? So over here you can see lie 1 and 3 are substitution instances of that sentence form, and why 2 is not. But let's add some more stuff. Sentence number 4, is it a substitution instance of that form? Yes, it is. And here is why. The form just has one truth function that connects the horseshoe that connects the left and right hand side. So that's the shape. One truth function that connects the left to the right. A sentence can have more truth functions than a form and still be the same shape as that form, and still be a substitution instance of that form. However, if a sentence has fewer truth functions than the form, it cannot be a substitution instance. Similarly, if a sentence has different truth functions than the form, it cannot be a substitution instance. You can have different truth functions than are in the form so long as you have all of the truth functions that are in the form. Now, let's take a look at squiggles. Okay, let's look at this form, just the atomic, the variable p. Is this sentence a substitution instance of that form? Yes. Is this sentence a substitution instance of that form? Yes. Yes. Now, don't get tricked by this not being squiggled and this being squiggled. The question is not about truth value, it's about shape. And both of these can be substituted for that variable, as well as this. So all three are substitution instances of that shape. Now we add a squiggle. That's the new shape. Is A a substitution instance? No. It has no squiggle. Is this a substitution instance? Yes, the squiggles match up. This is a hard question. Is this a substitution instance of that? Yes. Yes, it is. Why? Here, there's just one squiggle. It was the last thing we did in building that sentence form. Here, the squiggle is the last thing we did in building that with. And so, we not just have the same truth function, but, and now we have to introduce a new idea, the scope size of a truth function. That's the last thing we did. By definition, the last truth function you use to build a with, that is the truth function of largest scope. Because the last thing you did, if it's a truth function that has something on the left and something on the right, everything in the with will be to its left, and everything to the right of that in the with will be to its right. This truth function has larger scope than the dot because it's the last thing we did. Within the scope of the dot are just the symbols B and C. That's the scope. Within the scope of the wedge are the symbols A, B, dot, C, and the parentheses. So when you are the truth function of largest scope, and you have something on your left and something on the right, everything to the left of you is in your scope, and everything to the right of you is in your scope. For the dot, that is not true. Everything to the left of the dot is not in the scope of the dot, only the B. And everything to the right of the dot is not in the scope, only the C. So scope size is just a matter of what symbols are to your left or to your right, and if you're a squiggle, what symbols are to your right. That's the truth function of largest scope. That's the truth function of largest scope. Since they agree on truth functions and their scope size, they are substitution instances. That's extra. Over here, truth function of largest scope. Truth function of next largest scope. Is A a substitution instance?
No.
Is squiggle A a substitution instance? Only squiggle, squiggle A. Largest scope, largest scope. Next largest scope, next largest scope. So you need to determine in doing exercises involving substitution instances, the scope sizes. And here is where the book does not tell you something you need to know. And it's a very simple exercise that you'll probably get right without knowing this. That's the form. Okay, that's our form. That's our first sentence. Is this first sentence a substitution instance of that form?
Yes.
Who says yes? And that's good, it is. Who says number 2 is a substitution instance? Excellent. Now, let's go through this. Here is a simple method you can use for determining substitution instances. Step 1, look at the sentence form and determine the truth function of largest scope, horseshoe. Step 2, look at the sentence and determine truth function of largest scope, horseshoe. If they match, continue. If they don't match, stop. No match, no substitution instance. So, yes, they match. Now continue. Now look for the substitution instance of next largest scope. According to the book, the dot and the wedge are the next largest scope, and it doesn't matter, as I said, when you're building truth tables, what you do next. So, dot, dot, next largest, wedge, wedge, good. But if you followed the book, you would then say, that's also good. And it's clearly not. You could say, dot, dot, next largest scope, wedge, wedge. What you have to do in defining scope is to define a property scopes have, namely geographical position with respect to truth functions of larger scope. This dot is to the left of a truth function of next largest scope, and this is to the right. So the information about geographical position counts in determining scope size. The reason why the dot matches is that it is also to the left of the horseshoe, and the wedge is to the right of the horseshoe. Here, it is not a substitution instance because to the left of the horseshoe in the sentence is a wedge, and to the left of the horseshoe in the form is a dot. No match, no good. So geographical position needs to be included in the account of scope size. Yes?
What if we have a dot on both sides?
Then it doesn't make any difference. That's an excellent question. then it doesn't make a difference. To say there's a dot to the left of the horseshoe and a dot to the right of the horseshoe, won't make a difference. Now, squiggles can present a problem. That's the form. And here are 3 sentences. So what's the last thing we did in building this form? Squiggle. So that's the truth function of largest scope. What's the truth function of largest scope down here in number 1? The squiggle. It's the last thing we did. So they match. Step 2, what's the truth function of next largest scope in this form? The wedge. Match? Yes. What's the smallest truth function? Squiggle. Match? Yes. Okay, now, largest scope, squiggle, largest scope, squiggle. Now, this is where things get very tricky. What's the next largest truth function in here? In this form, it's that wedge. What's the next largest truth function in here? That squiggle. Is the squiggle the same as the wedge? No. See how tricky that is? And the same thing, right away you can reject this. Same thing is going on. One last thing. The book does not even do these. Namely, where you have repeated variables in a form. And they are the hardest part of logical form. Okay. That's the form. What's the truth function of largest scope? Horseshoe, horseshoe, match, continue. Next largest scope, squiggle, squiggle. Okay, you've exhausted all the truth functions in the form, but that is a repeat of that. Whatever is substituted for P, you have to have for the other occurrence. So that matches, A into P, A into P, that's good. Number 2, is that a substitution instance of that form? No, because A goes into P, and you'll have to have an A over here for that, but you don't. And just to reaffirm, Okay, this is not a substitution instance of that form. This is a substitution instance of that because you have different variables. Is this a substitution instance of that? Yes, it is. Why? If you have a different variable here, you can put the same thing in it that you put in P, or you can put something different. That this is different imposes no restrictions on what goes in it. Both go in. But when you have the same variable repeated, it imposes a restriction. Whatever you put in the first occurrence, the same thing has to go in the next one. Is 3 a substitution instance of that? Horseshoe, horseshoe. Squiggle, squiggle. Squiggle A goes into P, but I don't have a squiggle A left over because those squiggles matched up. I would need another squiggle A over here, so that's no good. Is this a substitution instance? Yes. Horseshoe, horseshoe. Squiggle, squiggle. Squiggle A goes into the first occurrence. Squiggle A goes into the second occurrence. Good. Is this a substitution instance? No. Horseshoe, horseshoe. Squiggle, squiggle. Squiggle, squiggle A went in over here, but I only have squiggle A left over. No good. So when you have multiple occurrences of the same variable and squiggles, things can get tricky. But it's really very simple when you are determining whether one thing is a substitution instance of another. First, look for the truth function of largest scope in the sentence form and see if the same truth function is of largest scope in the sentence. If it is, continue until you've gone through all of the truth functions in the form. And if you get matches all the way, you have a substitution instance. Unless you have repeated variables, and then you have to pay attention to whether the same thing goes into every subsequent occurrence of the first occurrence of that repeated variable. So that's it.